a network problem, just go check on the live videos on not my Instagram, but on the YouTube channel and the Facebook channel. Are you ready? Do you have your pen and your paper? So remember, I want you to, for those who have not submitted, please, here is your final chance to submit to make sure you have marks. So please, 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 to those who have not submitted, listen closely. I'm saying what you're going to do is you're going to write with me right now and you're going to submit as corrections. Can you hear me? Yes. Seth, are you in class? Okay, for those who need the link, you tell me so that I send the link for submission. Okay, I'll check attendance at the end of the lesson, and then I'll be able to follow those who didn't. Right, let's get started. This is the first assignment, so I'm just going to be moving fast. We have 4 assignments, so we are doing the assignment solutions together. So let's see how you're supposed to do it perfectly to make sure you are going to get 100%. So I'm going to do it for all your assignments. If you stop seeing my screen, please make sure you tell me, right? Right, so this is assignment number 1 that we are doing solutions for, which you should submit, is variation and selection. We're going to be doing past paper questions that I did. I'll put another one, maybe, I don't know, I'll think about it. Variation and selection. So no, not variation and selection. Sorry, just variation for maths, okay? We are not doing biology. I'm getting, because I wanted to teach you that in biology, but it's fine. We are doing variation, and that's the topic we're doing right now. Now, remember what you must know. Here's what you must know. You'll get it better as we go along. What you must know is that if they say something varies as, let's say they say y varies as x, or is directly proportional to x or whatever, what you do is you're going to convert it to an expression. If you're given as a sentence, the first step is to convert to an expression like this. Y varies as x. This is how you write it, okay? Then if they say y varies inversely, if you see the word inversely, this is what you do if you see the word inversely. If they say y varies inversely as x, you say y is proportional to 1 over x. If they say y varies inversely as x squared, that means it will be y is proportional to 1 over x squared. If it's inverse, then it's going to be 1 over. That's going to be the step number 1. Then step number 2 will be to remove this fish, and you're going to put an equal sign. When you put an equal sign after removing this, you put a k on the right hand side. So this becomes kx. Same thing you do here. You remove this, you put an equal sign, you put a k on the right hand side. But if it was a fraction like this, the k will now go and multiply the top. So it will be k over x squared. It's the same thing. Okay? Have you seen it? Then we can start to solve. Then what we will now do is we'll always need to find this k. We will need to find this k. When we have found it, we can answer any question that we have been given. So here it is. Remember, this question is coming in your exam, probably in paper 2 or in paper 4, or both in paper 2 and in paper 4. Are we together? Everybody? Are we together? So here is going to be the first one. Y is inversely proportional. So they've given you as a sentence in the first one. So that you're going to read y is inversely proportional to x plus 2 squared. So you have to write that. You have to convert it. Let me make sure that YouTube is not cutting. All right. Good. Here you have to listen now. What you do here, you have to make it, you have to change this sentence into the first form. We said inversely proportional. Once you see the word inverse, you say y is going to be proportional to 1 over whatever they will say here. So they said y is inversely proportional, which means you say y, then you put your fish facing the left. Don't change. If you have a habit of changing things, then you're not doing well. You don't change. These rules are not to be changed. So you're going to say y is proportional to 1 over what? They said x plus 2 all squared. So you now say x plus 2 all squared. This is the first step. If you don't have this step, then you're not going to get anything. So this is y is inversely proportional to x plus 2 all squared. Then now you change this. This becomes y is equal to, what did we say the next step is? You remove this fish. You now put a k. K over x plus 2 all squared. Well done. Then now look at what they say. They'll give you y and they'll give you x at some point to use to find k. So you're going to come here and you say, let y be equal to, what did they say? 8. Then x be equal to, what did they say? 3.5. X be equal to 3.5. You write it like this. Now you're going to say, where there is y, we are putting 8. So we put 8 is equal to k over, where there is x, we're putting 3.5. So it's 3.5 plus 2 all squared. All squared. And what we want is the k. So we take this to the other side. 8 now multiplies 3.5 plus 2 all squared. And it'll give you k. 3.5 plus 2 is 5.5. So x now multiplies 5.5 all squared. And you get k. Put it in the calculator. You could have even put it into the calculator earlier. So you now say 8 now multiplies 5.5 all squared. And you get 242. Being your k. Are we together? Is that it? Make sure it's the one. Let's see. This was 3.5. And here x is 3.5. Have you seen it? Then now you get your 242. Are you seeing, students? Okay, good. So here, now we go on. We're going to now say y, you rewrite, say y is equal to k over, no, instead of k, you can now put 242 over x plus 2 all squared. Then now you have this as your first thing. What are they now saying? W is proportional to x. Another thing, we do the same thing again. W is proportional to x. This is what we are now doing now. W is proportional to x. Then what are they saying? When you have written W is proportional to x, they didn't say inversely, so you just put your fish facing the left and you put your x. Which means now when you remove this and put an equal sign, it will be W is equal to kx. Right? Now, this is another k. It's a k2. So now what you're going to do is, what are you going to do? They said, find y in terms of W. Look at what you're now doing. Since you're saying W is equal to k2x, you can now make x the subject again. Then you come and feed it here. So let's make x the subject. You say here, since w is equal to k, let's put this k, find this k. That's the next step we always want to do. We want to remove this k. K is not supposed to be there. You use this one where you are given both information, w and x. So you come in and you say, let w be equal to 15 and let x be equal to 90. You're going to have 90 is equal to k2 by 15. No, w is 15, okay. 15 is equal to k2 by 90. Because the x is the one which is 90. So now you take 90 to the other side. 15 over 90 is equal to k2. What is 15 over 90? You get 1 over 6 is equal to k2. So now you can write and say w is equal to, instead of k2, you now say 1 over 6 times x, which means w is equal to x over 6, okay? Because it just multiplies the top. It's a whole number, so it just multiplies the top, which is 1. It becomes x over 6. You take 6 to the other side, you now have 6w is equal to x. So now we have 6w being equal to x. We just come and we put it here. So you're now going to say y is equal to 242 over x plus 2 all squared. Now you say let x be equal to 6w. Let x be equal to 6w. You now get y is equal to 242 over 6w plus 2 all squared. And now you have y in terms of w. Have you seen this? There we go. So 242 over 6w plus 2 all squared. Those who don't have this assignment, Could you please make sure you are writing these corrections? Yes, did someone call my name? Yes? The what? The? Where did I get it? K2? I got it from this here. To say W is 15 when X is 90. So let W be 15, X be 90. Do you understand? From this second statement here, W is proportional to X. So I wrote W is proportional to X. Then I have to remove this proportional sign. Pardon? Yes, it's the second K. The K's are not the same. You don't use the first one in the second. Yes, each relationship has its own K. You understand? Okay, that was the question. Yes, each relationship should have its own K. Well done. Good question, just to make sure. Okay, Simon, I'm going to give you. Right, let's go on. Next step. This is this one. This is easy, I know. Let's move fast, okay? Let's quickly do the solutions. We need to quickly finish them because we don't want to make this harder than it is. We have the fish already. Come on now, students. They didn't even give you the relationship. They gave you the fish already. You know the steps. Listen, you are a mathematician, so you don't break steps. May that day never find you where you throw away all this and you start doing your own methods in questions. That's the deadliest thing. Steps are to be followed, no matter what comes. Come rain, come sunshine, come thunder. So you know that for this topic, it's this easy. That's how we make sure we always get things correct, guys. That's how we get our 100%. So here we have the fish already. Y is proportional to the inverse. So this means Y is inversely proportional to X, whatever this root. Now we know that when we have this, we remove and we put the K. So Y is equal to, without reading anything, you don't read this. Remove the fish and put an equal sign. Okay, remove the fish, put an equal sign, but you then need to put a K. And this will be the square root of X plus 1, the root of X plus 1. Now what do we have now? Y will be then equal to what? You now, once you have it in this form, then you can use this information you've been given. You now say let X be equal to 8 and Y equal to 3. Which means now, wherever there is Y, we are putting 3. Wherever there is X, we are putting 8. So you're now going to say 3 is equal to K over, because there is one thing we hate, and that's K. K always has to go. He has to go, this guy. So it's going to be the square root now of, where there is X, we are putting 8. Be careful there. 8 plus 1. This now becomes 3 is equal to K over the square root of 9. 3 will be equal to K over the square root of 9 is 3. You take it to the other side. 3 by 3 is equal to K. 9 is equal to K. So you can write now to say, in this form, the equation, but now you know what K is. So you now say Y is equal to, instead of K, you now put 9 over the square root of X plus 1. Okay? Square root of X plus 1. We say to you, well done. Well done. You are very good at it. Now the next step you do is you now come here. You now come here and this, okay, they said find Y in terms of X, so you're done. You've already found it. So this is your square root. This is your final solution. 9 over the square root of X plus 1. Then you get your marks. So easy, because they only wanted that. Now we come to here. Y is inversely proportional. So now they are giving you as a statement. Careful there. You write it. Y is proportional. They say it inversely proportional. So it's proportional to 1 over whatever they will now say. They say it's X root X plus 2. So root X plus 2. If it's inverse, we will say 1 over. We will. If they don't say inverse, we just put the stuff. But it's inverse, so we say 1 over the square root of X plus 2. Don't make a mistake here. It's illegal. Next step. Remove this fish, put an equal sign. So you put an equal sign, then you put K. So it'll be K over the square root of X plus 2. Then now what do? We have been given the X, we've been given the Y. Put them, remove K. We don't want k. He is an enemy. Enemy number one. So you're going to say, let x be equal to 2 and y be equal to 3. So now you're going to say, where there is y, we are putting 3 is equal to k over the square root of, where there is x, you're putting 2. So 2 plus 2. You now say 3 is equal to k over the square root of 4. 3, it will be equal to k over root of 4 is 2. You take 2 to the other side, you are going to have 3 by 2 is equal to k, which is 6 is equal to k. So 6 will be equal to k. Now, are you done? Yes, surely you are not going to end here. When you find k, come and remove it from the equation here now. So you now say y is equal to, instead of k, you now say 6 over the root of x plus 2. I'll say, what a smart person. Well done. So you now put here 6 over the square root of x plus 2. Are we together, students? Are you seeing this? Students, are you seeing this? Okay, well done. Now you come to here. Y is directly, don't let no words cost you. You know what to do, you know the steps. Read the thing from the first line and convert it to a relationship. Y is directly proportional, so you don't put any 1 over. So you put y, then you put your fish, is directly proportional to what? Square root. Don't ignore the square root. Don't pretend you didn't see it. You saw it. It said square root of that. So put the square root. Square root of x plus 1. There we go now. They're directly proportional now. There's no 1 over anything here. We didn't put 1 over anything because there's no word inverse here. Gotta get rid of the k now. We hate him. We don't hate him, but we don't want him there. He is a massive disturbance, that guy. So get him off there. How do you get him off? You now need to remove by putting these. You know your 10.5, you know your 8. So you say let y be equal to, yes, you can ask the question. Somebody wants to ask a question? No question? All right, so y will be 10.5 and x will be 8. Yes, you can ask the question. Well done, Taha. Well done. Let's go now. When we say y is 10.5, x is 8. So now remove. Where there is y, please put 10. Don't mix it up. Don't you make such small mistakes. You are too old for that. Where there is y, put the y. Y is 10.5. So don't mix it. Don't take 8 and put on y. No, you can't do that. So y is 10.5. So put 10.5 there. So you say 10.5. Be careful, huh? Is equal to k, then the square root of, where there is x, you actually put the x, which is 8. So it'll be 8 plus 1. Be careful. You now say 10.5 is equal to k multiply root of 9. Pardon? Pardon? You now say 10. Where are we getting the k? We are getting the k at this step. Hwaba? When you remove a fish and you put an equal sign, you have to put k, or else you are wrong. You have to put k on the right hand side when you put an equal sign. Okay, Khwaba? Yes, you can ask the question. No, we ain't gonna do that. That's a different one. This last sentence, we are only coming to it if we have removed k. So we are not even looking at this one right now. This one is, we are not even looking at it. We are not going to put x equal to 8 there. That's a different one. This statement of x equal to 1.56, we are not working with it right now. Right now, we want to get rid of k. Root of 9 is 3, so k by 3. Did you hear me, Hwaba? Tell your mind this, Hwaba. Tell that mind of yours to say, when you remove a fish, Hwaba, I'm talking to your mind now, not to Hwaba, not to the eyes. Direct to the mind. Listen, tell your mind, when you remove the fish and put the equal sign, you are forced by maths, which you can't break unless you want to fail. You are forced by maths. It's a rule that when you remove the fish and put an equal sign, you have to put k. or else you are completely wrong and we don't know what you are writing. We are not going to look at your work. So when you remove the fish, tell the mind it's hard. It's hard, so I have to do it like this. Tell your mind, everybody, right now, when you remove this fish and put an equal sign, if you don't put a K, then I don't know what math you are doing. The math you are doing, I don't identify with it. If you put an equal sign, I want to see a K. And you now have to find that K by now saying y is 10.5. So you say let y be 10.5, then x is 8. Then you say x equal to, on the next step. So now you remove the y, you put 10.5 where there was y, you put where there was x, you put 8, then you solve until you find k. Then when you find k, you rewrite this equation that had k, but now you'll be removing it and putting its actual value. Come on, guys. So now you have 3, you take 3 to the other side. 10.5 divided by 3 is equal to k. What is 10.5 divided by 3? Tell me. What is 10.5 divided by 3? 3.5. So 3.5 is your k. Well done. Now remove it here. You're done a good job. So y is equal to 3.5 multiplying the square root of x plus 1. Then now you can come here now. Once you have this which has no k, the only way of getting rid of k is by knowing its value, then removing it. That's the only way. Now when you have it like this, you are a boss. You are an amazing person. You are ready to solve any question. Here they are saying find what? They are saying find y when x is this. So they are telling us the value of x. We put here on x. Then we see what answer for y we'll get. So we will now come here and we say let x be equal to 1.56. We will now say y is equal to 3.5 square root of 1.56 plus 1. Don't make any mistake anyway. Remember to rewrite this, but remember to remove k and put what k actually is. Then now you can answer this one. So you will now put let x be, then you now say y will be equal to this. Don't change my steps. Come on, students, don't change them. So what is this now? Y will be equal to, can somebody punch this exactly as it is? 3.5. Then you can open your bracket, you say the square root of, you say 1.56 plus 1, that's 2.56. Can you do that? Tell me what you get. What is y going to be? What will be your answer here? Okay, you got 7.8 as your y. Let me see if that's the answer. This is number what? Y is proportional to the square root of x. What's the answer? Let me punch it. So let me punch it. 3.5 roots 2.56. It's 5.12. Didn't anyone get 5.12? No, I'm sorry, I made a mistake. 3.5 open bracket root of 2.56 close is equal to 5.6. I got 5.6. Did anyone get 5.6? 5.6. Great. Great. So this is the correct answer, okay? Any solutions and whatever? Yes. Should we continue now? Should we continue now, everybody? This is called variation. This topic is called variation. Yes, it's called variation, which talks about proportional or variation, stuff like that. Let's see here. M is inversely proportional to the square root of t plus 2. So M is proportional to 1 over. Before you read this last part, when they say inversely proportional, you say M is proportional to 1 over. You say 1 over. You put your fish, then you say 1 over. Now you say what? Square root of t plus 2. So root t plus 2. Are we together, students? Then now, what do you do as your next step after putting this? You put an equal sign. When you put an equal sign, what's the rule? Bring in k. So you put k at the top. If it's a fraction like this, k goes on top, root of t plus 2. Okay? It's just multiplying, so it's the same as that other part. So nothing changes. K multiplies the right-hand side. Now, what do I do here? I've got k. I now come to read this thing which they tell me. I'll now say let m be equal to 0.5 and t be equal to 23. So where there is m, I put 0.5. Don't mix it up. Is equal to k over square root of, where there is t, they say put 23. So you say 23 plus 2. So you now get 0.5 is equal to k over 23 plus 2 is 25. So root 25. You get 0.5 is equal to k over 5, because root of 25 is 5. You take 0.5 times 5 is equal to k, because 5 goes to the other side. It will now multiply. To get k, you get 2.5 equal to k. So my k is 2.5. Well done. You now come and replace in this equation. So you now write m is equal to, instead of k, you put 2.5 divided by the square root of t plus 2. Are we together? Hello, everybody? Okay. Well done. Now, what do we do here now? What do? We can now answer any question. Because we no longer have k, we have an equation, everything is good now. You can come to this one now. We said find m when t is whatever. So you just go be right. You say let t be equal to 98. Then m will find itself. M will be equal to 2.5 over the square root of 98 plus 2. So m is equal to 2.5 over the square root of 100, which is going to be m. What is your m now? It's going to be 2.5 over 10. Your m will be 0.25. There we go, 0.25. We are going to get the best results in the whole world. Let's keep going. What are we going to do here? Just follow the steps. If you follow the steps, you're a powerful person. Because you're going to get a different question in your exam. It's going to be yours. It's going to be your question. So respect the steps. If you want marks, respect the steps, students. Here we've already been given the relationship. You should be able to clearly explain to me what you are doing because you're following steps. You tell me, sir, I already have the fish here. I already have the relationship. The only thing I have to do is remove that fish of theirs, put an equal sign. And then I will put a k when I'm putting an equal sign. But when I first rewrite what they gave me, y is proportional to 1 over root x. I say true. You say I'm going to remove this and put an equal sign. I say yes. Then you say when I remove an equals, I put k on top of root x like this. I'll say true. Then now you have it. What do you do when you have k? You come to this relationship they've given you. You say let x be equal to 9, comma y be equal to 2. So now where there is x, we are putting 9. Where there is y, we're putting 2. Where is y? It's here. We put a 2 is equal to k over the square root of, where there is x, we are putting 9. So root x. So 2 is going to be equal to k over root 9 is 3. We take 3 to the other side. 2 by 3 is equal to k. Now 2 by 3 is 6. 6 is equal to k. There we go. We now have k. So now we're going to write y is equal to, instead of k, we put a 6. So it will be 6 over root of x. There we go. 6 over root of x. Now they said find the value of y when x is 36. You will now write here to say let x be equal to 36. Y will be now equal to 6 over the root of 36. Y will be now equal to 6 over root of 36 is 6. Y will be now equal to 1. So your y will be 1. You get your marks. Come on now. You see, you're going to get 100 if you do this for every particular question. Because you're following the steps. So nothing will touch you. You're fine. Here they've given you as a statement here. Why is that? Can you write my corrections? If you're in class right now and you didn't write the work, can you just write all my answers, all the corrections, and submit them? You'll get your 60%. It's better than 0. You need it. I told you you need it. Y is directly proportional. It's direct. So you say Y. Remember, direct and inverse, it's the same thing. You still put a fish. But for inverse, you would have said 1 over. For direct, you don't say 1 over. You just put your fish, then you read the second part. It's proportional to what? X minus 1 all squared. So it'll be x minus 1 all squared. This is the first step. What a good person. What good steps. Then now remove that fish of theirs. Put an equal sign. We want an equal sign. So you say y is equal to, when you put an equal sign, the right side now gets a k. K multiplying x minus 1 all squared. Y will be now equal to, now that you have your k, once you have your k, you go and read this statement. You say now, let x be equal to 4 and y be equal to 3. So now you're going to say, where there is y, you put 3. You say 3 is equal to k multiplying, where there is x, you're putting 4. 4 minus 1 all squared. 3 is going to be equal to k minus 4 minus 1, that's 3 all squared. Then 3 squared is 9, so 3 will be equal to k by 9. You take 9 to the other side, 3 over 9 is equal to k. 3 into 3, 1. Into 9, 3 is equal to k. K is 1/3. So you can now write where there is the equal sign, which is on this stage here. You remove the k, you put 1/3. So you say y is equal to now 1/3 of x minus 1 all squared. Are you seeing it? All right, so now this is going to be it. Now multiplying 6 squared. Can somebody do that? Multiplying by 1/3 is like dividing by 3 class. So can everybody say 6 squared, then you say divided by 3. What do you get? 12. I got it before you. I thought you were the ones with the calculator, guys. Questions, anyone? All right. How many questions are left? 2 more. I hope you wrote my corrections. I definitely hope you did. Y is inversely proportional, which means Y, you put your fish, then you put 1 over. Inversely proportional to the square. Don't, come on. To the square, they didn't say the root. So it is proportional to 1 over, then you say x plus 3 all squared. Are we together? Can you see this? Square root, if they say the square root, they'll say it. Look at it here. To the square root. Can you see here? Here they say to the square of x plus 3. So you do it like this. X plus 3 all squared, which means y is equal to 1 over x plus 3 all squared. No, k over, sorry, not 1 over. If you leave the k, you are cooked, you're in trouble. Now, once you have k, you say let x be equal to 5 and y be equal to 0.375. Now you can deduce it. Where there is y, you put 0.375 is equal to k over. Where there is x, you put 5. So it will be 5 plus 3 squared. What do you get here? 0.375 is equal to k multiply k over. What is 5 plus 3? That's 8 squared. So you can now bring it to the other side. 0.375 by, don't you dare say 8 squared is 16. I'll run away from you. 64. That's 8 squared. It's 64. So it'll be k over 64. You can now say 0.375 by 64 will be equal to k, because 64 will come to the other side to multiply. What's 0.375 by 64? It's 24. Is equal to k. There we go. Now what are we going to say? y is going to be, instead of k, you now put 24 over x plus 3 squared. Last one. Y is inverse again. Inverse, so there's 1 over there. So you say y, you put your fish proportional to 1 over, because they said inversely, proportional to, then they said x squared. So you put your x squared in the bottom. Now what do you do? Remove the fish, put an equal sign, but you put the k on the right hand side. It's like this. Now, once you have it like this, you use this. You say, let x equal to 3 and y be equal to 2. Now, what do we do here? Wait, somebody needs to mute the mic. I'm not sure who it is. Check everybody. I can't see, but somebody has to mute the mic. Check your mics, check your mics. Right, now we'll be saying x is 3, y is 2. You now say where there is y, you're putting 2 is equal to k over where there is x, you're putting 3, 3 squared. 2 is equal to k over 9. You take 9 to the other side. 2 by 9 is equal to k. 2 by 9 is what? 18. 18 is equal to k. So this becomes your k, not the y, your k. So you now rewrite here. Step number 2, you rewrite it once you have k. Y is now equal to 18 over x squared. Now you can answer any question, which is this one. They then ask you, find y when x is 2. You just say let x be equal to 2. Y will be now equal to 18 over 2 squared. Y will be equal to 18 over 4. What is the answer? What is 18 over 4? 4.5. Is it not? And you're done. You get all 3 marks. Well done. You get all 3 marks, and we say to you, well done. That was just so amazing. That's fantastic. Are we together, students? Great. So for this assignment, you've written the corrections. Those who didn't write, have you written the corrections? No more hiding. No more hiding. I want my corrections. Let me do one more. The other ones, I'll do them tomorrow, I guess. I don't want to do mean. I want to do similarity. Where is the... To send what? Yes, you may. Did you write them down? I hope you wrote them down. Why didn't you write the other ones? I'm moving too fast. Write these ones now, Hwaba. Write with me on this one. This is the last one, everybody. Then we will do the ones for physics where you had the lenses. So let's do these ones. Are you all watching? Let's do these corrections now here for similarity. The past paper questions. Yes, somebody called my name. Oh, okay. I should send what? Oh, you want the PDF version of things. Okay, still fine. I can send it. I'll send the PDF version. But yes, I'll send the PDF version. It's not a problem. Now write for me this one. Assignment 2 that we are doing today is, it's not variation now. There's a similarity. You write and you submit. If you haven't done it, okay, I want to see your submission. It will be now corrections. I'll give you a 60%. That's what happens in university. There's what we call a sub-exam. So sometimes if you don't do well, you get another chance, but you get 60%. You get just a pass. For university, it will be 50%, because the C for university is 50. But for IG, the C is 60. Are you ready to start? Hello, everybody? Right, let's go through it. I want you to look closely so that you see what you should do here. Okay? All right, good. It's a bit of work here. I did this one because it's the harder one. I want to start with the more complicated things. Okay? So let's go. Let me explain something here. Can you all just write the things that we use? The first thing is that original length, I'm going to be writing it in shortcuts. You see, times scale factor gives you the new length. So, sir, what does this mean? Because I can see this sentence of yours that you like to write, but I may never be able to use it because I will not be able to understand. So, listen. If you are dealing with, I want to be able to say this. If I can make you understand this, my job is going to be done. This is the hard part. Listen closely. If you are dealing with lengths, in this topic called similarity, they'll tell you that you have similar shapes. So you actually know you are doing the topic of similarity because they'll say you have similar shapes. So once you see the statement, you have similar shapes, you are in this topic of similarity. So that's not the problem. The problem is not you knowing you are in the topic. The problem is knowing what to do in the topic. The first thing you must know is that when you are dealing with the shapes, you must always find which one you are starting with, which one you are ending with. And I'm going to show you how you know. You know which one to use as the original. I'm going to show you just now, okay? But here's the thing. Listen. If the thing you are dealing with is length, let's say height or the length of a side, as long as it's length, then the thing that is relating length is called scale factor. So you must write this relationship of scale factor. You should say original length with the whatever length that you will decide to be the original. Whatever you decide to be original will always be original. It can't change. Then if it's length, then you'll be using scale factor. It will be equal to new length. If you're using areas, you're going to say whatever you decide to be the original area, you will multiply it by area factor to get the new area. So if you are dealing with areas, surface areas, especially surface areas, those are the ones you deal with mostly, you use area factor. I don't want to see scale factor on areas. That is a severe lack of judgment. You don't do area factor on lengths or scale factor on areas. You are in disaster mode already. Then the last one, original volume times volume factor will give you the new volume. So if you are dealing with volumes or capacities, capacity is volume. By the way, this could be capacity. Capacity means volume. When you see them say the capacity of this container, they are telling you the volume. Okay? If they say capacity, you are dealing with volume. You have to use volume factor. So say, what is hard about this topic from your experience? What do people struggle with? People struggle with this first part of identifying that it's areas you are dealing with and using area factor. People think that it's scale factor for everything, which is the biggest lie I've ever seen in the whole world. You can't have a relationship between two areas and you are relating them using scale factor. Hey you, what are you doing? Don't you know that's wrong? Areas are related by area factor. Volumes are related by volume factor. Lengths are related by scale factor. So scale factor is strictly for lengths. Please. You are smart. Stick to this, please. Now, the next thing which you then need to do, because the tendency of the mind is your mind doesn't want it to be having different ones. It wants one so that the working is short. But you are wrong. You are not going to create a new version of maths. If you want shortcuts, you are gone, sir. Volume has its own, area has its own, and length have their own. Period. It will never change. So listen now. You have to do this whether you like it or not. Then now when you want to change from one thing, you get volumes, then they ask you about areas. That means you now have to change. Because for volumes you were having volume factor. Now you want for areas, that means you'll be now using area factor. How do you then change like that? Let's say you had sides, Now they are asking for areas. You can't use the scale factor for areas. You are in trouble if you do that, because scale factor is not for areas. Scale factor is for lengths. So you now have to change again. Do I have to change again? Yes, you have to change again. Is there no other thing? Like, let's say I don't want to change. You have to change. Yes, you have to change. So how do you change? Here is the relationship. Watch closely, everybody. Here is the relationship. Give me a second. Something is happening with the network. Here is the relationship for changing now. You should know that scale factor squared is area factor. You only have to know this. Then you should know that scale factor cubed is equal to volume factor. You should know this one again. And you are done. Are we good? Students, have we agreed? Guys, are we agreeing, guys and girls? Okay. So this is now how you're going to be moving from one to another. You'll be using these two relationships. So make sure you write this relationship down and this one, you know them. If you know these, then come on now. You are good, ma'am. You are good. So you come here. Let's now see the steps, because now I've given you the info. Now we need questions. Questions bring experience. Experience brings perfection. So now let's use a question. Sir, how do we do it? Listen to the steps. I always love steps. I love steps. Steps solve things. Listen to this. The easiest question that you can ever get is if you see the word similar. Remember, we are in the topic of similarity. So I said they are going to say something about similar. So for you to know that this is now a question of similarity, you will see the word similar. So here they have used that word similar. So we know we are in similarity. Now listen, if they give you these two shapes like this, this is actually the easiest version, because you are only dealing with sides. You are only dealing with lengths. There is nothing to do with area here. There is nothing to do with volume here. But other questions can actually bring you a mix. So this is actually the easiest one. You don't fear this one. This is the easier one. What you do, listen now. Listen to what you do. There is going to be a small side and there is going to be a big side. So here is the rule. Listen. We know that we are dealing with sides, so we are going to have OG times scale factor is equal to nu. Why scale factor, sir? Because we are dealing with sides. Now, who is going to be the OG one? In this case, it's going to be the small one. The small one is going to be the original one. Do you know why? Because the one you make new is the one that has something missing. You're going to listen to this rule. It's going to work for you forever, from now on till forever. The one which has something that is missing will be the one which goes this side. It's the missing one. So we are going to use that idea. Let's now get to work. So I'm going to come here and I'm going to see, all right. So this one has this side which is missing. So it's the one that is going to be the new. And it's the larger one. So what I'm going to say small. I'm going to say the length of the small. Okay, because that's the original one, times the scale factor should give me the length of the large. You're good. Well done for doing that. Now you're going to choose which length of small do you want to start with. You start with this one because you also know the length on the large, because you want to find the scale factor. So what length of small do we have? 10. So you say 10 times scale factor, which you don't know, is equal to the same length on the large shape, the same length which is here, 45. So a length on the small one, 10 times the scale factor. Why scale factor? Because we are dealing with sides, lengths. Is going to be the same length on the large one. Why did you put large on this side? Because it's the one that has a missing side that we'll find in step number 2. So we started with this 10 because we have him here, 45. We can't start with 14 because we don't have him. He's an X. We don't have him. We can't start with him. So now look at it. You're going to say 10 times scale factor. You now say scale factor is equal to 45 over 10. The biggest secret to success is you mustn't panic. And the only way for you not to panic is you follow steps. So you look at your shapes, you see, is it the small one? You're going to do this for about 10 questions. We have questions below this. So you're going to get better as I keep doing. So just listen closely. As I keep doing, you are going to get better. The secret is the one who has something missing is the one we will put on the other side. Anyway, it could be the small one, it could be the large one. I don't care. You don't care. The one who goes on this side is the one who has something missing. And it could be scale factor, it could be area factor, depending on what we are relating. Are we relating areas? Are we relating volumes? Are we relating lengths? Here we were relating lengths, so we used scale factor. So now you're going to say, therefore, your scale factor is equal to 45 over 10. That's 4.5. You have your scale factor. Then you rewrite this same statement because you want to use it again. The length of the small one times scale factor is equal to the length of the large. Now, what is the length of the small? 14. We now want to find x, right? So we now say 14 times, what's the scale factor? You just found it, 4.5. So now you can continue. Is equal to, what's the length of the large? X. You know, if you get in the exam, then you try a shortcut to quickly get x, you are in serious trouble. So now you're going to now say 14 times 4.5. What are you going to get? What's 14 times 4.5? Good. 63 millimeters is equal to x. Then you leave. You know, if you go out of an exam having written things like this, you will be the most confident person I know. Because you know you followed rules. You know you got it correct. So look at this second one. I want to grill. There's something I want to grill in you which will help you solve this one, because this can be a tricky topic. This can be a tricky topic if you don't follow steps. Okay, I've scrolled up. Have you seen it? Great. Now let's go to the next one. Question number 2. The surface areas of two mathematically similar. Hey, you are in an exam, you see the word similar, you say, sir told me we are dealing with similarity. Okay, similarity. Sir told me we are dealing with similarity. So when you're dealing with similarity, you should know in first step, what have you been given for both shapes? Here they've told you the surface areas. So you've been given areas, so you're going to be dealing with area factor. Listen closely here. So you're dealing with areas. Oh, so I've been given 2 areas. One will be small, one will be large. Look for it. This one is obviously the smaller one. Then this one is obviously the large one. So now you want to know which one is original, which one is new. Come here and look at the question they are asking you. Find capacity. We said capacity is volume. Find volume of larger. So who has something missing? Don't worry about the fact that they want volume, whatever. We are not yet thinking about volume. We know that they will want volume, but that's not what we are looking at. Listen to what you look at. You look at what in the first step. What have you been given for both? You've been given areas. You know the area of the small one. You know the area of the large one. But now you want to know, am I going to say area of large times area factor is equal to area of small? Or am I going to say area of small times area factor is equal to area of large? What do I do? You see who has something missing. Here the larger container has a missing volume. So he will be the one that goes alone. So you're going to start with the small one because he has everything. So you say area of small times area factor. Why am I using area factor? We are dealing with areas. This will give me area of the larger. Sir, why did you put larger one this side? Because we know in step 2, we will be looking for him. He is the one who has something missing. Don't change. So now what you're going to say is, what is the area of the small one? 124. 124 times, do I have the area factor? No, I say AF is equal to, do I know the area of the larger one? Is 279. Then now I'll say area factor is going to be 279 divided by 124. And I can get my area factor. What is it going to be? What is the area factor going to be? What's 279 divided by 124, class? $255. Pardon? 2.25. So now, look at what you then do. Look at what you then do now. You now say, next step wants volume. So I need volume factor. The only way to get volume factor, you need to change area factor into volume factor. How do you do that? You use the two relationships. You first, since you have area factor, you first say scale factor squared is equal to area factor. Now you want the scale factor. You already have the area factor. So you take this squared, you take it to the other side. You now have scale factor being equal to the square root of area factor, which means scale factor is equal to the square root of 2.25. What is the scale factor going to be, class? What's the square root of 2.25? $1.5. That's going to be your scale factor. Now you want to change it to volume factor. You now say scale factor cubed is equal to volume factor. So you should know this relationship. Scale factor squared is area factor, and this one, scale factor cubed, is volume. And you should know how to use them. Here we are using them now to come from area factor to volume factor. You now say scale factor cubed is volume factor. So you now say 1.5 cubed gives you your volume factor. What is 1.5 cubed? Somebody? It's 3.375, right? This gives you the volume factor. So now you have volume factor. What do? You are ready. You now say volume of small, because you had said area of small. So volume of small times volume factor is equal to volume of large. Don't change the order. If you had said it's going to be volume of the larger one. So volume of the smaller one. What is the smaller one? Here, capacity of the smaller container, which is the volume of the smaller container, 56 mils, times the volume factor, 3.375. This will give us the volume of the larger one. What is it going to be? 56 times 3.375. What do you get? What do you get, students? 189 mils. This is going to be the volume of the large. So 189 mils. Are we together? This becomes the volume of the large. Is this hard? No, it's not hard. We come here. Two mathematically similar. We are in similarity. Okay. Now, what is it that I have for both containers? Solids have volumes, this and this. Obviously, this is going to be the larger one. And obviously, this is going to be the smaller one because it has the smaller volumes. And what you have is volumes. So you have volumes of both. But so now, obviously, since you have volumes of both, your first sentence is going to be on volumes. It's going to be something times volume factor gives you something. But then you need to see in step number 2 what you will be looking for. You will be looking for height of the larger. So since you're looking for the larger one, again in this question, larger will be alone. So you're going to say, since you have volumes, you start with the volumes. Volume of smaller times the volume factor gives me volume of larger. Now, what is the volume of the smaller? 4.8 times what's the volume factor? We don't know. Gives me volume of, no, sorry, it's not 4.8. Volume of smaller is 24. Here, 24 cubic centimeters. Okay, if you want to put the units, times volume factor gives me volume of larger, 81 cubic centimeters. Now, how do I get volume factor? I take 24 to the other side. Our volume factor is equal to 81 cubic centimeters divided by 24 cubic centimeters. What do you get here as your volume factor? Very, very strong, students. What are you going to get here? Okay, wait. YouTube, Quantum Pulse, you said you have a doubt. Explain the question. It's what? What do you get as your volume? 3.375. You can even leave it as a fraction if you want. But 3.375 is not a bad one. So you can leave it as that. Normally I would have left it as a fraction, but you can leave it as 3.375. It's still fine. So now what you're going to now do is you say the what is 3 point, what is, if I reduce to lowest terms, what is 81 over 24 when you reduce to lowest terms? Somebody put in your calculator and tell me what you get. Am I still in the lesson? Can you all hear me? Okay. It's 3 over 8. Good. It's 3 over 8 or 8 over 3. What is it? Three over 8. No. You mixed it up. 81 over 24. Oh, 3 over and 3 over 8. Press second function, then say A, B over C. I want it as an improper function. Okay, let's just keep it as 3. Okay, wait. It's dangerous. It's dangerous. Let's keep it as 3.375. I don't want any mistake here. So now, okay, that's good. We have volume factor. Now, but we see on step number 2, we are going to be looking for the height of the larger solid. The height, so that's a length. So we're going to need scale factor. So we need to change from volume factor. Anyway, we only have that one method we know. Scale factor cubed is equal to volume factor. This is the relationship between scale factor and volume factor. So you now take cubed to the other side. Scale factor will be the cube root of volume factor, which is going to be the cube root of 3.375. Somebody, can you tell me what you get as the scale factor? Scale factor is equal to what? Say second function, then press this x cubed. It becomes cube root. Then say 3.375. What do you get? Oh, Simon, I'll help you. I'll help you. I'll help you, Simon. What do you get? 1.5. So this is 1.5. So now we can write the last one. We can say height of small times scale factor, because we are now dealing with lengths. Are we together? Okay, give me a second. Seems like one of my lives has been disconnected. Right, let's finish it. If you can stick to these tips, then I know you're going to be safe. Okay, should we finish? Can we go on? Can you all hear me, guys? Okay, my network is not the strongest. The place where I put my Starlink is a bit of obstructions because I changed locations. So you forgive me. But anyway, it will be better. It will be better. Let's continue now. What are we saying? This you now say, what is 4.8 times 1.5? What do you get? You'll be now done, eh? What is 4.8 times 1.5? 7.2. And this is centimeters. It's equal to the height of the larger. So can you see that the steps are actually not a lot? Just look at how many things we wrote. It's just a few sentences, just these ones and these ones. The hardest thing is to control your mind, the steps to do, because it has its own. You have to fight it. Trust me. Once I got that message, there's a part where I learned that, my problem is my mind. I have to tell it to stick to these laws. Once I got there, I could always get answers. Tell your mind that the only way to come from volume factor to scale factor is this one. If you leave it alone, your mind will tell you there's another way, and it will lead you to being stuck. Because it will tell you there's another way, and then when you ask it, what other way? It doesn't have. So tell it, hey man, the only way I'm going to change from volume factor to something else is to remember the relationships. So you have to remember these relationships. Scale factor cubed is volume factor, and scale factor squared is area factor. I should just have them in case I need them. Make your mind have them. They're the powerful things. Anthony, shall we together? Good. Here's another one. Slow down. Look at this shape. What did I tell you? I told you that this part A is the easiest, where they give you some signs and they ask for another, because you are just going to be using relationship between one side to get relationship between another side. You don't have to change from volume factor to area. There's no changing here. We are only going to use scale factor because the only thing we have is sides for these two things. So this is the easiest one. Now what we just have to find out is which of these shapes, the bigger one or the smaller one, which one has something missing? Which one has this PR that they're looking for? Is it the bigger one or the smaller one? Tell me. Where is PR? Students, is it on the bigger shape or on the smaller one? On the smaller one. So the smaller one is the one going to its own side. Don't change it. So and since we are dealing with lengths, we are working with scale factor. So you're going to say length of larger times scale factor is equal to length of smaller. Please, I hope you are obedient people who will follow the steps. Now, let's start with a length that we know on both sides. Which one do we know? We know this one where it's 9 and here where it's 6. So we can say length AB, it's a length on the larger one, times the scale factor should give us the same length on the smaller one, which is length PQ. On the smaller one, it's called PQ. So what is that length AB? It's 9 times scale factor gives us the length on PQ. What is it? It's 6. So now we will say scale factor is going to be 6 over 9. And your scale factor will be equal to 3 into 6, that's 2. 3 into 9, that's 3. So it's 2 over 3. This becomes your scale factor. Then you do the same relationship here. Length of larger times scale factor gives me a length of smaller. Stick to the plan. Length of larger. Now that you know scale factor, you are very powerful, is equal to the length of smaller. What is the length of the larger one? Which is the same as PR. PR is this one. So on here, it will be 12. So you say length AC times scale factor gives me length PR. What's length AC? 12. Times what's the scale factor? 2 over 3. should give me length of PR. Tell me, what is 12 times 2 over 3? You say 12 times 2, then divided by 3. What do you get? You get 8. 8 centimeters is equal to length PR. So you just come and you say here 8 centimeters. And you get your 2 marks. Do you see? We are strategic. We follow steps. That's why we know we will get all answers. Because we are people of steps. I'm teaching students of steps. Let's come to this one. Triangle ABC and triangle PQR. So it's the very same triangles. Now they are saying here, they are mathematically similar. Yes. The volume, and they want volume of the larger one now. So look at what we do here. Be careful, right? Since on here, the scale factor that you found, this 2 over 3, you found it by saying length of larger. So you're not going to change. First of all, change it to volume. You say scale factor is equal to 2 over 3. Scale factor cubed will give me volume factor. So 2 over 3 cubed will give me volume factor. 2 cubed 8, 3 cubed 27. This gives you volume factor. Volume factor is 8 over 27. Now, since you said length larger times scale factor, you will now say volume of larger times volume factor gives volume of smaller. Because you started with larger on scale factor, so you must start with larger on volume factor, or else you are lying. So now, what is the volume of the larger one? We don't know. We don't know it. Volume of the larger, we don't know it. Times, what's the volume factor? 8 over 27. This gives me the volume of the smaller. They told you the volume of the smaller. It's 1120. Now you take 8 over 27 to the other side. You have volume of larger. When you take a fraction to the other side, it will be 1120 times the fraction will flip. 27 over 8. Then you get the volume of the larger. Can somebody tell me how you get volume of the larger? Say 1120 times 27. Then you say divided by 8. What do you get? Say it. 1120 times 27, then divided by 8. Tell me what you get. (3,780 cubic centimeters). 3,780 cubic centimeters. Are we together, everybody? Okay. I want all my corrections. All my corrections. 1, 2, 3, 4, 5 questions left. Let's do this one. Let's do this one. We'll be done in 10 minutes, I guess. Right. What I want is steps, because you're going to be stuck again. This is the beginning. The beginning of every question is tricky. Laura Lehakwa. The beginning of every question is tricky. I know that. So that is why I'm grilling into you how to start. Don't run away. Fight until you are confident of how you begin. I look at these two shapes. Listen. What I'm looking for is what have I been given for both shapes, because they are going to change the structure of the question and everything, because I'm going to see the word similar and I'm going to know similarity. My first thing is, what have I been given for both shapes? Surface area of B. So I've been given areas. This is the smaller one. Here they are calling it A and B. Yeah? Smaller, this is larger. We can still call it A and B. Okay, so we have areas. So we are going to deal with the area factor and areas in the very first sentence. But now we want to know which one has something missing. It's B. B has something missing. So we are going to say area of A times area factor is equal to area of B. Why are we putting area of B on this side? Because he is the one that has something missing on step number 2. Oh, so because he is the one who has something missing, he's the one who goes alone? Yes, he's the one who goes alone. Okay, sir, that's fine. But why did you do areas? Because those are the ones we are given for both shapes. Step number 1, you don't start with what they are looking for. You never find it. You start with what you are given for both shapes. You've been given areas. So we are doing areas. And who do we put on his own side? The one who you are going to need in step 2. So now what is the area of A? A is the smaller one here. The area of A, this is the area of B. Area of A is 60 times area factor, we don't know it yet, is equal to area of B, which is 540. Area factor, so this, if you want, you can say 60 centimeters squared will give 540 centimeters squared. Area factor will be 540 centimeters squared divided by 60 centimeters squared. What do you get? Area factor will be the zeros cancel. 6 into 6, 1 into 54, is that 9? Area factor is 9 with no units. Area factors, these scale factors, area factors don't have units. Now, since you want scale factor, you take this square to the other side. Scale factor is the square root of area factor, which means scale factor is equal to the square root of 9, which means that the scale factor is equal to 3. Now you can go for it. You now say height. Since you had said area of A, you now say height of A times scale factor now, because you're dealing with lengths, will give you height of B. What is the height of A? Do you have it? Yes, 7. So 7 times, what's the scale factor? Do you have it? Yes, 3. And it's 7 centimeters, by the way. Is equal to height of B. What is 7 times 3? 21. Of what? Centimeters is equal to the height of B. So this is 21 centimeters. Thank you for your attention to this matter. Are you seeing this? Okay. Look at this one. Can somebody tell me what is the first step? What do you look for in step number 1? The information that you have been given for both shapes, right? Is it volume? Is it area? Is it length? Surface area, blah, blah, blah. I'm not even, the moment I read the word similar, look, you don't get marks because you are reading this way. The diagram shows 2 mathematically similar solids. The surface, this is the way you guys have been reading since standard 1. And I don't want to see it. I'm into results, guys. Anything that has a chance of lowering your results, I don't want it. You reading this the way you were reading in primary and lower secondary and all this time is deadly, because you are filling your mind with details that are not important. What is important is for you to see the word similar. You skim in questions. You look for what topic it is. So you see the word similar, you know you are in similarity. Now, if I am in similarity, I have to find what has been given for both shapes. Surface area of the larger and surface area of the smaller. Oh, so I'm going to be relating with area factor here. Surface, the area of the larger by area factor, giving area of small, whatever. Now you see, which one has a missing thing? You know you're going to be relating using area factor. Fine. Which one is a missing thing? It's the smaller one, because it will have a missing volume. So that means he is going to be alone. So you are going to say area of larger times area factor gives you area of smaller. Are we together? Why did you use areas and why didn't you use volumes? Because volumes are for step 2. Areas are for step 1 because that's the one we've been given for both. So now what is the area of the larger? You look, there's 200 and there's 98. Obviously the other one is 200. So 200 centimeters squared times area factor gives you the area of the smaller one, 98 centimeters squared. How's that? Now what do you do to get area factor? What do you get now? You say area factor is equal to 98, this is centimeters squared, divided by 200 centimeters squared, which is going to be, what is 98 divided by 200? .49. Is it exactly 0.49? If something which is not exact, what is the square root of 0.49, guys? 0.7. You said 0.7. Okay. Thank you. So now, let's go for it. We'll now say, we want volumes. So we now want volume factor. So scale factor cubed will give you volume factor. What is the scale factor cubed? 0.7 cubed should give us volume factor. What is 0.70 cubed? What is it? Can you now do it? Because we now want volume factor. 3.43 is the volume factor. Oh, 3.343 is the volume factor. Now you're going to just say, since you had said area of larger, you say volume of larger times it's what? 0.343. Now, since you had said area of larger, you say volume of larger again. But now it's times volume factor gives you volume of smaller. So what's the volume of larger? You go and you check. Here, the volume of the larger solid is this. So you now say 450 times what's the volume factor? 0.343. This gives you volume of the smaller one. Volume of smaller. What is it? 450 times 0.343. What do you get? It's what? What will be the answer? Say it. Yes, tell me, what's the answer, guys? $154.35. Volume of smaller. Any question? Thank you. Well done. Okay, these last two I'll give you to try. I need to give you to try. So, for maths, we end here, right? Yes. For maths, I think I'm proud. I'm happy with where you are. You tried the last two, which is this one. The last three, rather. And this one and this one. You try. Submit as my corrections. If you have forgotten the steps, come back and watch the video and until you remember the steps. Are we together? Yes, Blinky. I see you, Blinky. You've got a question? No, Blinky. It's not pre-recorded. No, it's not pre-recorded. It's not pre-recorded, Blinky. I'm in a lesson with my class and I'm streaming on YouTube. So I'm actually in a lesson with people. Okay, Blinky? All right. So this is it. Let me stop the streaming here. This is the last question I'll do for this. And then you can go back and check all the ones I did below. Class, please do the last three. Those who are in my class, please do these last three. And if you haven't done them, and fix. Okay. Blinky, I'm about to stop the live video. I want you to go behind and rewatch what you missed, and then you'll be fine. Okay? You just go to my channel, then go to live videos, you see it. All right, everybody, that's it, right, guys? Antonisha, for maths, I'm ending here. I'm going live to do the bio solutions now. Let me check the register first. Mark the attendance. Hi, Hassan.